adding and subtracting polynomials. Our objective is to add and subtract polynomials. Who uses this? Business owners can add and subtract polynomials that model profit. Let's start with adding and subtracting monomials. Notice how each term is a monomial here. So we got one monomial, another one, and another one. Okay? So basically we're going to simply combine like terms. So we have 15m to the third. There's also another m to the third. So we can combine those together to get 17m to the third, and the 6m squared just sits all by itself. Let's try this next one. We have a 3x squared and a minus 7x squared, and then we have this positive 5 and positive 12. When we combine our 3x squared and our negative 7x squared, we end up with a negative 4x squared, and then a positive 17 when we combine our 5 and 12. Take a moment and try C and D on your own. When you return to the video, the answers will be revealed. So when we combine 0.9y to the fifth, negative 0.4y to the fifth, and 1y to the fifth, we end up with 1.5y to the fifth. And then this 0.5x to the fifth, we can't do anything with it, so it stays. Just because they both have a power of 5 doesn't mean you can combine them. Their bases have to be the same as well. In D, you have 2x squared y minus 1x squared y minus 1x squared y. So when you subtract the first one, now you're down to 1x squared y, and then you're subtracting the next one, so there's nothing left. So it's just 0. So now let's try adding polynomials. So notice how you're adding a binomial and a trinomial. Well, the same thing applies. You're adding, so you're just going to combine like terms. So you have this 2x squared and this x squared here. So we have 3x squared. And then we have a negative x and a positive 3x. So we end up with positive 2x. And nothing goes with this negative 1, so we're just going to simply rewrite it. Now let's try this one here. So we have a negative 2ab plus 2ab. Those cancel each other out. And now we have a b and an a. They can't go together, so you're just going to simply write b plus a. Try these next two on your own. When you return to the video, the answer will be revealed below. So let's look at C. We have 4b to the fifth, a 3b to the fifth, and a negative 7b to the fifth. When you combine those, you end up with 0. Your other like terms are 8b, 6b, and b. When you combine those, you end up with 15b. 0 and 15b are just going to give you 15b. So now let's look at D. You have 20.2y to the second, and then you also have a 1.7y to the second. Together, they make 21.9y squared. There's no other y's on it by themselves, so you just have plus 6y. However, we have a 5 and a negative 8, which give us negative 3. So now that we have adding, let's try subtracting. You have this 2x squared plus 6 minus this whole quantity, which in this case is just a 4x squared. So if you have 2x squared minus 4x squared, you're going to end up with a negative 2x squared. There's nothing else the minus goes with, so you just rewrite this positive 6 right here. This is where it gets a little tricky. You have a binomial and you're subtracting this entire trinomial. So you have a to the fourth and 3a to the fourth. You have a minus 2a and a minus 3a here, and this 1 doesn't really go with anything, so it's on its own. Well, we have a to the 4th minus 3a to the 4th, which leaves you with negative 2a to the 4th. And now you have this negative 2a minus, this minus is still here, okay? So negative 2a minus negative 3a. So it's almost as though you're distributing this negative across. So negative 2a minus negative 3a is like saying negative 2a plus 3a, because minus a negative is like saying add a positive. So that leaves you with positive 1a. And now you have minus 1. So this minus still carries over, so it's a minus 1. Now you're completely subtracted. Try these next two on your own. When you return to the video, the answer will be revealed below. See how close you get. Alright, so let's look at C. We have 3x squared, and then we have minus x squared, so we're left with 2x squared. We have this minus 2x, and there's nothing else, so minus 2x. And then we have positive 8 minus negative 4, so minus a negative is like adding a positive, so 12. If it helps, you can think of it in terms of distribute the negative. So you're looking at 3x squared plus 2x plus 8 plus negative x squared plus 4. And then you would do the same thing as you had done earlier in the video. Let's look at D. So we have 11z to the third minus z to the third, which gives us 10z to the third. And then we have a minus 2z, and then minus a negative. So that's like adding a positive, so plus 5. Once again, if it helps, distribute the negative and then add like you did earlier in the video. Now let's try a business application. The profits of two different manufacturing plants can be modeled as shown, where x is the number of units produced at each plant. Write a polynomial function that represents the difference of the profits at the eastern plant and the profits at the southern plant. So it might be helpful to write this vertically. So we have negative 0.03 x squared plus 25x minus 1,500. And then we're going to take that quantity and we're going to subtract negative 0.02x squared plus 21x minus 1,700. Notice how we lined up the x squareds and the x's and then the constants? This will make it easier to subtract vertically. If you need to, you can switch all your signs over, just like we did in this example here where we distributed the negative, or you can do it as you go. So we have negative 0.03x squared minus negative 0.02. That's like adding a positive. So we end up with negative 0.01x squared. And then we have 25x minus positive 21x, which leaves us with 4x. And then we have negative 1,500. So don't forget that negative sign there. So negative 1,500 minus negative 1,700. So minus a negative is like adding a positive. So therefore, we have negative 1,500 plus 1,700. Once again, we're adding the opposite, so we're adding a positive in here, and that gives us positive 200. And there you have it, folks. That ends our video lesson on adding and subtracting polynomials.